In 1964, the only measure of blood flow to the brain was the Ketty-Schmidt nitrous oxide method. It required needles in both an artery and an internal jugular vein or bulb for frequent sampling during a 10-minute period of breathing 15% nitrous oxide. Flow was computed from the integrated AV nitrous oxide content differences between jugular vein and artery. That is a measure of the the difference of across the barrier is a measure of blood flow, but it's not a real measure of flow, whereas the Ketty-Schmidt method actually computes the flow exactly. Tom Hornbein joined us by helicopter in 1964, and here he is arriving by helicopter at Barcroft. This was just a year after he ascended Everest by the West Ridge. Hornbein is the subject in this picture. 15% nitrous oxide is being mixed by Larry Seidman, some of you know, using old flow meters. Internal jugular bulb blood was sampled by Ed Munson. Both of them were UCSF anesthesia postdocs that year. Well, what we found is shown here. The CBF, cerebral blood flow, went up within 24 hours at 3,810 meters altitude. It went up about 25%. After 4 days, it has fallen to about 13% above sea level controls. But with acute normoxia, the cerebral blood flow remained 8% above normal because it was then driven by the altitude-induced metabolic acidosis of the spinal fluid. This 3-day acclimatization CBF remains acclimatization fall of CSF bicarbonate to about 20 millimoles per liter reset the relationship of CBF to PCO2 and CSF pH. In 1990, Krasny and Lassen showed that CBF remains high in hypoxia if the PCO2 is prevented from falling. You can't do that in people, but he did it in goats. In 1963, I took my portable homemade blood gas analyzer to Peru to study pH and of CSF and arterial blood. In 20 high-altitude natives of villages at 3,700, 4,500, and 4,800 meters of altitude, the CSF and arterial pH values were not significantly different from sea level, averaging about 7.33 and 7.43. But surprisingly, the PCO2 was 32 millimeters of mercury at all 3 altitudes, although the mean SaO2 saturation fell as expected from 90 to 84 and then 81 at the highest altitude in the natives. In 1965, Cedric Bainton, who was then a new anesthesia faculty member, but many of you know him from running the anesthesia department at the General, he and I studied the hypoxic and CO2 ventilatory responses in high-altitude natives living in Cerro de Pasco, Peru at 4,400 meters. The canisters were used to raise the PCO2 for tests of the hypercapnic ventilatory response, HCVR. And I will tell you later about Bainton's pulmonary edema, which occurred his first night there at 4,400 meters. Well, here's what we found, and it was surprising. The upper curves, 5 of them, are of newcomers. 5 of us newcomers, the mean acute isocapnic hypoxic increase, which I called delta VE, at 40 torr, was estimated from the study to be about 21 liters a minute. In altitude natives, the response was only 1/4 as much. That's the full black stuff at the bottom of the picture here. The mean responses were not significantly different in 4 polycythemic altitude natives with a hematocrit over 70 from the other normal Irwin subjects also living at Cerro. This blunting of high altitude natives' hypoxic chemosensitivity was confirmed a year later in Sherpas living in high altitude Nepal by Millage and Lahiri.